The purpose of this video is to show the advantages of the new artificial neural network of the PNet type compared to the multi-layer artificial neural network trained by the back propagation method when used to predict the movement of Forex quotations. I will demonstrate number 1, creation of an automatic expert advisor for the MetaTrader 4 terminal by training a neural network of the PNet type on Forex quotation data. Number 2, testing the expert advisor based on the trained neural network of the PNet type in the strategy tester. 3, creation and testing of an expert advisor based on a multi-layer neural network trained by the back propagation method. And number 4, comparison of the training speed and the results of testing the advisors based on both types of neural networks. On the terminal panel navigator, there is a list of expert advisors, indicators, and scripts. The components of the PNet software package, PNet EA generator, are also located here. Make EA is designed to create expert advisors by training neural networks using quotation data based on the trade signals. Make signals is intended for automatic generation of trade signals on the chart of quotations. Signals are standard graphic objects of the terminal. Up arrow is to buy, down arrow is to sell. For the automatic signal generation, run the Make Signals Expert Advisor. Parameters of the automatic signal generation for the Euro-USD M15 chart. Bars count, the number of bars in which the price fluctuations will be searched, equal to 5 bars. By points, the number of points of price fluctuation when it moves up, equal to 30 points. Sell points, the number of points of price fluctuation when it moves down, equal to 30 points. The period where the signals are set is from January 1st, 2016 to January 1st, 2018. The signal set periods does not include the beginning of the year 2018 in order to test the expert advisor's operation on quotes outside the training set. For example, make a front test. In our case, the signal will be set before 5 bars if the price fluctuation inside them is less than or equal to 30 points. Signals can be edited or initially set manually. To create an expert advisor by training the PNet, run the script Make EA. Enter or select script parameters. Input bars on pattern, the number of bars to the left of the trade signal for use as a training set pattern, which means that in this case, a single set of neural network training data pattern will look like 12 inputs, quotation data, and 1 output, 0 for a supposed sale transaction, 1 for buy. Next, select the number of layers, PNet levels, and training epochs. Enter the name of the generated advisor and choose the type of PNet for training. After the expert advisor is created, select Update in the Terminal Expert Advisors list to compile a new one. Now we can start testing the expert advisor obtained by the PNET training. From the list of expert advisors in the strategy tester, we choose the one that was just created. Select parameters of the expert advisor. Take profit, stop loss, is set equal to 30, which corresponds to the parameters by which the trade signals were automatically generated. Each signal is set before the price fluctuation of 30 points. Other parameters of the expert advisor, except for the percent of permissible neural network error, delta, are not related to neural networks and will not be considered in this video. We choose the testing period to be equal to the period in which the PNET training was conducted, from January 1st, 2016 to January 1st, 2018. Run the test. When the test is finished, we see the results in a tabular form. The Results tab in the form of a chart that displays the curves of changes in balance and funds. On the horizontal scale, the transaction numbers are displayed. On the vertical scale, balance. When you hold the cursor, detailed information about the transaction balance and funds is displayed. On the Report tab, the information is presented as a summary report. As you can see, the percentage of profitable trades is about 70% of the total number of trades. This is the result of testing in the period in which PNET was trained. Next, we carry out the front test that tests PNET operation on the data outside the training set for the period from January 1st, 2018 to March 20th, 2018. The result is 68% profitable trades of the total number of trades. Now we will train the neural network to one of the standard implementations with training via back propagation of an error. We train it using the same data and with the same parameters. We do not change the signals on the graph. Now we run Make EA. Choosing the name of the advisor, the type of neural network will be left by default. As you can see, the training speed is much slower than the training speed of the PNet. The number of training epoch is 1,000. For PNet, this number can be reduced without loss in training quality. We will demonstrate these tests in the next video, and in these cases, the parameters of training and testing of neural networks are identical. First, we update the list of advisors to compile the newly created advisor. Second, we choose a new advisor in the strategy tester. Third, we select the testing period equal to the period in which the neural network was trained. We select the parameters of the expert advisor identical to the expert advisor created on the basis of PNet. Then we will run the test. We can see the results are not satisfactory. About 51% are profitable trades in the data period at which the neural network was trained. The results can be slightly improved if the percent of the permissible neural network error, delta, is reduced. To do this, we change the corresponding parameters by open delta and cell open delta of the expert advisor. We reduce the error percentage from 1% to 0.001%. The improvement in the percentage of profitable trades is only 2%, 53% of profitable trades instead of 51%. Now we will carry out the same experiment with an advisor based on the PNet. We change the corresponding parameters of the advisor, reducing the error from 1% to 0.001%. As you can see from the report, the result is now 92.42% of profitable transactions instead of the previously obtained 70%. However, a decrease in the neural network error leads to a reduction in the number of transactions especially in the period outside the training set. When testing the period from January 1st, 2018 to March 20th, 2018, with the chosen error perimeters, there are no trades. Thus, we can say that P-Network, with similar training perimeters, significantly surpasses existing analogs in training speed while demonstrating acceptable forecasting abilities. In this video, we have demonstrated the simplest example of training and comparing neural networks. Many experiments are still to be done. Further PNet development and improvement will achieve even more impressive results.